A concrete beam of symmetrical I section has an effective span of 8 meter. The width of beam is 400 mm and thickness of flange and overall depth is 80 mm and 500 mm respectively. Web thickness is 80 mm. It is pre-stressed by a parabolic cable with an eccentricity of 150 mm at the center and 0 at the supports. The effective pre-stress force is 180 kN. The live load on the beam is 8 kN per meter. Draw the stress distribution diagram at 3 meter span from the left for the condition pre-stress plus self-weight plus live load. For the given data, the first step is always to draw the sketch rightly. For the given data, let us draw the sketch. The dimension is given, the width of the beam is 400 mm and thickness of the flange is 80 mm and the overall depth is 500 mm. Accordingly, the sketch needs to be drawn carefully. It is a symmetrical I section, equal flanges. Width of the flange is 400 mm, thickness 80 mm, overall depth is 500 mm, and thickness of the web is 80 mm. And the longitudinal section has to be drawn clearly. So here the type of the cable, it is parabolic cable. So let me draw one two-dimensional sketch. And this represents the neutral axis. It is given clearly in the statement that the cable given is parabolic cable. So it is given that it is having an eccentricity of 150 mm at the center. So this represents eccentricity at the center, and at the supports it is 0, which means at the support there is no eccentricity. It is coinciding. So it has to be drawn carefully. So this is the cable with respect to centroidal axis. So this is the centroidal axis, and with respect to this, let us draw one parabolic cable. So here this represents central eccentricity, and at the support it is coinciding. So here there is no eccentricity, that is 0. So at this junction the eccentricity is 0, and also it is given that stress distribution plot has to be made at a distance of 3 meter from the left to support. Therefore, a section has been considered here for the distance of 3 meter. The length of the beam is 8 meter. Once this sketch is drawn clearly, the rest of the calculations can be made easily. A pre-stressing force is given as 180 kilonewton. Since it is a symmetrical I section, there are two number of the flanges. Flange dimension is 400 into 80. Web or the rib dimension is 80 by 340. And make the final calculation. And moment of inertia. The entire I section can be idealized as a rectangle section, and later you can deduct two number of the exterior rectangle, and that is how the moment of inertia can be computed. Section modulus is defined with respect to the moment of inertia and the depth of the neutral axis. The overall depth, since the overall depth is 500, it is a symmetrical section. 500 divided by 2 is 250, and substitute moment of inertia, section modulus can be obtained. And later dead load of the beam has to be calculated, and it can be calculated with the simplest equation, area into density. After substitution we get the dead load value as 2.18, and you have to draw one simply supported beam representing the uniformly distributed load here. As I have told you, a separate section needs to be considered at 3 meter section. And let us calculate the bending moment. If it is required to calculate at the central span, we have a direct equation WL square by 8, but however in this case we are not computing it at the central span section, we are computing at the 3 meter span. Therefore you have to take section and calculate the bending moment accordingly. So initial phase, you have to find out what are the reactions at the supports. You can consider this as support A and B, and then with that calculate everything. 8.76 is nothing but the reaction into 3 minus of 2.919 into 3 into 3 by 2, and finally we get the value as 16.43. And similar calculation has to be done for even for the live load as well. The live load value is 8 kilonewton per meter. It can be done in the similar fashion. calculate the reactions WL by 2 from both the sides, apply the bending moment calculation procedure, it will be obtained easily. Next, since the profile of the cable is parabolic in nature, finding out the eccentricity distance is important and crucial here. Since it is a parabolic cable, eccentricity has to be calculated carefully. Here the central eccentricity in the problem, it is specified as h is equal to 150 mm, but however we need to calculate it at the distance of 3 meter. In such fashion we can make use of the equation of parabola. So what is that eccentricity distance or the h distance or the y distance with respect to the 3 meter span? So we can make use of the equation of parabola, substitute all this. H is 150, x is nothing but where it is required to calculate, and L is the length of the beam, x is the point where it is required to be calculated. After substitution, eccentricity at 3 meter can be calculated and computed. Next, the rest of the procedure is very much similar to all the other conventional problems. Direct stress needs to be computed here. Direct stress, that is pre-stress due to the direct stress, it is sigma is equal to P by A. And next, bending stress due to the pre-stress is plus or minus ZE PE by Z. So as I have told you, if it is symmetrical section, Z remains same. If it is an unsymmetrical section, Z varies. It can be calculated. However, the sign convention changes here, plus minus. And bending stress due to the dead load is also calculated, plus or minus mg by Z. And bending stress due to the live load is calculated, plus or minus mq by Z. And lastly, the stress distribution plot needs to be done. Okay, as I've told you, the stress plot for the pre-stressing condition, that is pre-stress, direct pre-stress, it is positive, that is compression in nature, therefore entirely it is positive. Whereas in the second case, that is pre-stress due to the bending case, at the top fiber we have obtained as negative, minus PE by Z top, and whereas at the bottom face it is positive and it has to be connected accordingly. And we have to always draw the reference line depending upon the top value and the bottom value with respect to deadline live load. The stress plotting has to be done. Since we have got positive value for the both load cases, dead load and live load, it is drawn to the right hand side, and with respect to the bottom it is negative value, it is drawn to the left hand side. And finally the resultant stress calculation can be made by applying F superior and F inferior expressions, and if the final value is positive, the line has to be drawn to the right of the reference section, and if it is negative, stress plot will be done to the left of the section.